So this is just a sample of one of these physics type problems. We've seen them before, actually, about the distance. So we're thinking about a particle moving in a straight line, and they give us some function. Here our function is now this 9t over t squared plus 9. And we've done this before where we've calculated the velocity and the acceleration and answered questions about it. So here's like a slew of questions. Now that we can take derivatives of more complicated things, we can look at sort of a little bit more interesting problems than we did before, where we had to use just the definition of the derivative back in section whatever it was, 2.7 or whatever. So here's an example. Let me do this. Let me put a bar so that I try to write up everything so that you don't have to watch me write it up, but we're just going to have to use this area and kind of keep what we need. As we know, the velocity is the first derivative and the acceleration is the second derivative. So the first questions are asking me about the velocity, so I need to take the derivative of this. Of course, this is a product, not a product, a quotient, right? So I'm just going to take the derivative of this. So this would be t squared plus 9 squared in the bottom. And then I have t squared plus 9 times the derivative of the top, which is 9t, minus 9t times the derivative of the bottom, which should be 2t there. Okay? And here I do want to spend a little bit of time just cleaning it up a little, because it's going to make my life easier in the long run, right? So this is 9t squared minus 18t squared. So this is going to be minus 9t squared plus 81 in the top and t squared plus 9 in the bottom. Notice you can't divide it out, right, because of the minus. Is a different sign. Okay, also this has units. The units are in feet per second, because s was in feet and time was t in seconds. They told us that. And of course, we're starting time from t equals 0. So that will come into play in a minute. So they also wanted the velocity at t equals 1. So I'm just then going to stick in for part B. I'm going to stick in 1 for t, right? So I get minus 9 plus 81 over 10 squared, right? So what is this? 72 over 100. Okay, so that's the answer to part B. Part C, more interesting, right? When is the particle at rest? So the particle is at rest when the velocity is 0. So I want to solve for v of t being 0. Of course, that means the top is 0. So this is going to be minus 9t squared plus 81 is 0. So that's going to give me 9t squared equals 81. T squared equals 9. So t equals plus or minus 3. But really, we only care about the t equals 3 because we want values greater than 0. So my answer to part C, when is the particle at rest, is going to be when t equals 3. Now I need to have some more space. So what I'm going to do is I'm going to put this velocity up here, because I'm going to need that. Minus 9 t squared plus 81 over t squared plus 9 squared. And also my information, v of 3 equals 0, that I just found out there. Get rid of the rest of this. Because, and why do I need that information that it's at rest at 0? The next part of the question asks me, when is the particle moving in the positive direction? So if you remember what this means, if the velocity is positive, it's moving in a positive direction. If the velocity is negative, the particle is moving in the negative direction. Okay? So the question now is asking me for sort of part D is, when is the velocity positive and the velocity negative? Okay, of course, all we need is a sign chart for the velocity function, which we have right up here. And I can even start from 0 because I only care about t greater than 0. And of course, the other thing is, so to make the sign chart for the velocity, I need to know where the thing is 0. So that's where it's going to change signs. So this is obviously going to be 0 when t equals 3. Right? Because we already found that. That's why I kept it up there. Now, you also have to be careful. Remember, especially with a quotient, you might have an asymptote. So let's take a quick look at that. But we can actually see here that the bottom is always going to be positive. So we don't have any asymptotes. We don't have to worry about any sign changes with respect to that. All we have to worry about is when the top is 0. So now I can check this by just plugging in some points. Okay, so if t is less than 3, if I put in t equals 1, I'm going to get something positive. If I put in t equals 4, I'm going to get something negative. So I can now answer my question. The velocity is positive, so meaning that the particle is moving in a positive direction. So particle moving in positive direction is happening from t goes to 0, 3, and then in the negative direction, it's going to happen for t greater than 3. Okay, now what is the total distance traveled? Okay, so to sort of figure out what this really means, this was my picture, my sign chart for the velocity. Okay, but I can also imagine what's going on as time goes out. Here's t equals 0. What's going on? Well, actually, that's not what time. Sorry. This is going to be s. Sorry. So what is happening with my particle, right? So at the beginning, I'm at s equals 0. So let's just do s equals 0 here. And as time moves on, I know I'm moving in the positive direction. So if I'm here at 0 for the first 3 seconds, I'm moving in the positive direction, right? And then at t equals 3, I'm now moving in the negative direction. I don't know how far I'm moving because I didn't check that. So in order to figure out the distance, of course, I need to look at the distance function. But here I'm just sort of trying to figure out sort of mentally what's going on. So first I'm going, for 3 seconds, I'm moving in the positive direction, and then I'm going to move back in the negative direction. So now that I know that, I can actually answer this part E. If you think about it, what are they really asking, though? They're asking for the total distance traveled. They're not just asking for the displacement, right? Because if I look at what is the displacement, it's this big. This would be what I would get. So total displacement from t equals 0 to t equals 6, this would be s of 6 minus s of 0. It would be where I ended minus where I started. But total distance is more than that, because you see what I did is my particle overshot and came back. Okay, so if I want total distance, so they might just call this displacement, but total distance, I have to take the distance going in the positive direction and add it to the distance that I'm doing in the negative direction. So this would be the absolute, that would be like distance moving in positive direction, and I'm going to add that to the distance moving in the negative direction. And that's going to give me my total distance traveled. So, and what you're going to have if you write that out, like what is the total distance moving in the positive direction, I know it's got to be how far I moved between 0 and 3. It's 3 because we calculated it, right? That's where it changed. When I did my sign chart, I found out that for this function, I go forward until I hit 3, and then for the rest of the time, I'm going backward, okay? Because there's no other point here after 3, the whole thing's going to be negative forever, right? I'm not moving back. So I can tell you, regardless of what they said, 6, I'm still going to be moving backwards, right? So I have to do the part that I'm moving forward at 3. So that would be s of 3 minus s of 0. That's going to give me this distance. And I'm going to add it to the amount I moved backwards, s of 6 minus s of 3. And again, I don't know how long this is, whether I moved this much or I moved all the way back here. I didn't calculate. Actually, I do know because I did it. But, you know, a priori, you don't know how far that arrow goes. I'm just using kind of the arrow to illustrate what's going on. So let's actually figure out these numbers so we can see how good this is. We don't need this, and they didn't ask us that. They actually asked us for this. So let's see. Total distance, which was s of 3 minus s of 0 plus s of 6 minus s of 3. So s of 3, 27 minus, what is it? 3 squared is 18, right? Minus 0, right? And then s of 6, 9 times 6 is 54. And then it's 36 plus 9, so that's 45. Minus s of 3, which was 27 over 18. Okay, so this one is 3/2. And this one turns out to be negative 3/10, but it's the absolute value. So it ends up being 3/10. So my total distance traveled ends up being 6. No, what'd I do? Where's the answer? 18/10, right? 18/10, which is 9/5 feet. Okay, so meaning that with this picture, okay, things like I overshot a little bit. So this would maybe be s equals 1. Yeah, a little bit over here, right? Because this would be s equals 3/2. So I first go over 3/2, and then I go back, but now obviously I'm going a little slower, right? Because I go back an additional 3/10. Okay, and that is going to give me that. Okay, so that's how you figure out the total distance. So I have 2 more here. This is pretty much all I can answer, what they might ask you about using just the velocity. The last 2 questions deal with the acceleration. Okay, so the acceleration is the second derivative. So I have to take this velocity and take another derivative to find the acceleration. So again, derivative of velocity. And so this is going to be another quotient rule. So it's going to be t squared plus 9 to the 4th. And then t squared plus 9 squared here times the derivative of this, which would be minus 18t, minus this guy, which is 9t squared plus 81. And I'm running out of space, but I'm taking the derivative of the bottom here, so I have a 2 and t squared plus 9, and the derivative of that is 2t. So got a lot of chain rule in here too, because I've got the derivative with the square, and so when I take that, I have to remember I also am taking the derivative of the function inside. And so normally I'm like, well, you can just leave it like this, but we need to answer questions about this, specifically the same kind of questions that we asked about the velocity. So you can't leave it like this. You have to do some simplification. So we're going to simplify this up a little bit. You can see each piece has 1t squared plus 9. So that 1 is going to cancel. So what do I have? I have minus 18t cubed minus 18 times 9t. This is 4t. So plus 36t cubed minus 81 times 2t. And then over t squared plus 9 cubed. So if I work that out, because I did this with these numbers here. Okay. Oh, I was really lazy. Watch this. I didn't even do it out. I did 81 times 6t. I didn't multiply it out. Okay, and the reason I didn't multiply it out is because I know that I want to let this thing be equal to 0. Because the last part asked me when is the particle speeding up and slowing down. So I had to do the same thing as I did, right? Speeding up and slowing down, it's asking me about the sign of the acceleration, right? So I'm going to have to find out where this equals 0. So what I did was I just went ahead and factored this top part, pulled an 18t out of everything. Did it that way. Okay, and I just left it like that. So that is my acceleration. And then, of course, it asks you for the, oh, by the way, and of course, the acceleration is in feet per second squared. And the acceleration at the time t equals 1, we just put in 1, so that's easy enough to do. It's 18 times negative 26 over 10 cubed, so whatever that is. You see, I didn't bother to work that out. I probably should have worked that out, right? Anyway, so whatever that number is your acceleration. Again, it's negative. So what does that mean? It means that the particle is slowing down at that time, right? So the sign of the acceleration is going to, when the acceleration is negative, you're slowing down like you're braking. When the acceleration is positive, of course, you're accelerating, you're speeding up. Okay, so that is the last part of this problem. So I do apologize, these do get long, but it is what it is. Right? I'm not supposed to say that anymore. Okay. Since we don't want to be memes. All right, so here we have this thing. So the last part of the question is asking me, when is the particle speeding up and slowing down? Which means, just like before, I need to do a sign chart for this. So easy enough, right? I just have to find out where it's 0, because those are going to be the points on my sign chart. So luckily, this is easy to figure out where it's 0, right? Because this is t minus 3 root 3 and t plus 3 root 3. If I factor that top, and the bottom is never 0, just like before. So my points where it's going to be 0 are going to be t equals 0, 3 root 3, and negative 3 root 3, but I don't care about that one because I only want positive t. So if I look at my sign chart for A, all I have on it is 0 and 3 root 3. And then if I put in like a number, well, we actually already know we put in 1, so that was minus there, right? And then if I put in a number bigger, like if I put in like 10 or whatever, 9, right? It's going to be positive, right? So we're going to get that. So what that's telling you is that your particle is slowing down for t t going from 0 to 3 root 3. And then speeding up 4t greater than 3 root 3. Okay. And now I answered all the questions.